Lesson 29 for anyone that missed it or you want to rewatch it. Sure. Take a moment. Pause me. Do the do now. I'm going to go over it. So, spoiler alert, unless you want to just do it with me. So, last night I found an equation and I graphed it using a program, and here's what it did. We're going to use these two ideas, so I wanted to bring it back up. What is the y-intercept for this line? Well, the y-intercept is where our line crosses the y-axis, and that's over here at 0, -4. Okay. What's the slope of this line? Well, we have two things. We could do rise over run, or we could do our new slope formula. I'm going to do our new slope formula. Sure, why not? Okay, I grab any 2 points on the line. I'm going to grab 5, 0, and 10, 4. And I'm going to say, let's use our slope formula. So it's the second y minus the first y, and the second x minus the first x. And I find the slope of that line is positive 4/5. And just to prove it, from 5 to 10 is a change of 5, and from 0 to 4 is a change of 4. So using rise and run, we get the same thing. It's 4/5. Okay. We're going to focus on the y-intercept. The x-intercept is here listed on the x-axis, but we're going to focus on the y-intercept and the slope. Okay, so today's the big day. Day of days is what I call this day. And I get you in groups, and you do the problems, and you hopefully discover something really important. And if you can discover it on your own, you're more likely to remember it. And that's why I want you to do it. But what we're going to be able to do by the end of today is take any line and figure out the equation that goes with it. Like, by the end of today, you're going to discover something that's really kind of awesome about the equations for lines. And you're going to hopefully discover it on your own. So, I'm going to do the classwork for you here so you can see the work. And hopefully make the connection yourself. So here's the linear equation. We're going to make a table and graph it. Okay, and then we'll talk about the rest of the questions. So I can do this in my head, but put 0 into the equation. I get y equals 2 times 0 plus 1, which is 1. And then I'll do the same thing for 1. I put 1 into the equation for x. I get out 3. And then I could repeat that, but I know that linear functions have a constant rate. And once I see that it's plus 2, I can just use that pattern to find the next couple points. Saves me some work, right? All right, now I'm going to graph it. I gave you -1, -1. We got 0, 1, 1, 3, 2, 5, and 3, 7. We did a good job. We got a nice straight line. Okay, and then you kind of repeat that process. So maybe you want to do it by yourself. I'm going to go ahead and fill out the table. And I can do this in my head. I just take the x and do the math. And once I see a pattern, I can just follow it. So it's plus 3 each time. And I'll graph it. Good. Okay, keep going here. Found the pattern. Okay, nice straight line. Sweet. Okay, here. Ooh, this one's a little trickier. Let me see if I can figure it out. I'm going to put 0 in. I get 6. Put 2 in. Okay, now I can see it's just minus 3 every time, so it's going to get 0. Let me check. Negative 2, 9, 0, 6, 2, 3, and 4, 0. I got a, yep, negative slope here. Awesome. Okay. All right. Put this in. I got 1/3 times 0 plus 1. That's 1. 1/3 times 3 plus 1. That's 1 plus 1. That's 2. All right. Pattern. Plus 1, plus 1, plus 1, plus 1. All right, and I got a nice straight line, so I must have done it right. Okay, and I could do those in my head, but I just saw that it's minus 3 all the way down, so I just repeated the pattern. All right, negative 1, 5, 0, 2, 1, negative 1, 2, negative 4, 3, negative 7. I got another nice straight line. Sweet. All right, so those were the tables. Now it says go back and find the slope and y-intercept of each linear function. All right. I'm just going to do rise over run just to make it easier for myself. So I see the slope is 2 over 1. And the y-int is 0, 1. Okay. Over here, I guess I'll just do rise and run again. I get 3 over 1. So my slope is 3, and my y-intercept is 0, negative 2. I can also find that in my table for anyone that didn't notice. See, 0, 1, 0, negative 2. All right, this one. So my slope on this equation, this line is 1 over 1, and the y-int is 0, 4. Okay, over here, I get a slope of 3 over 2, but the line's negative, so my slope is negative 3 over 2, and my y-intercept is 0, 6. Perfect. Over here, 1, 2, 3, up 1. So my slope, it's positive 1 over 3. My y-intercept, 0, 1. Almost done here. Okay. 1, 2, 3, 3 over 1. So in the last one, my slope is, it's negative 3 over 1. And my y-intercept is 0, 2. Great. So I found the slopes for all of them and the y-intercepts. And then let me see. What does question 8 say? Compare the equation, slope, and y-intercept for each line. What do you notice? Okay. Well, I made this, so I'll help you think about it first before I give it all away. Look at the equation. Y equals 2x plus 1. Check out the slope. Check out the y-intercept. And then go back to the equation. Not seeing anything yet, Mr. Moran. All right, well, let's go to the next one. All right, so the equation is y equals 3x minus 2. Look at the slope. Look at the y-intercept. Look back at the equation. Wait, is that true? Am I seeing that right? Maybe. Let's see if it continues. Look at the equation. Y equals 1x plus 4. Check out the slope. Check out the equation. Wait, what? I guess so. Shut the front door. Yes, I think so. Let's just double check all the way through. I think you've seen it now, right? Look at the equation. Look at the slope. Look at the y-intercept. Oh, it does seem to work every time. Wow, that was a big waste of time, Mr. Moran. It's just right there. Again, check out the equation. Y equals 1/3 x plus 1. Check out the slope, 1/3. Check out the y-intercept, 0, 1. And just to confirm the last one, we got y equals negative 3x plus 2. Look at the slope, negative 3 over 1, and check out the y-intercept 2. Hopefully you've seen it. I think it makes sense. So what can we say? Well, it looks like the slope and y-intercept are actually in the equation. The slope is next to x, and then you have the y-intercept after it, right? And that's in all the cases. And that's true. That is huge, right? These equations, you see the slope. You see the y-intercept, right? In every single case. Slope, y-intercept, slope, y-intercept, slope, y-intercept. Okay, so what does that mean? Well, this is a big day. Normally we build it up. But I like to call today the day of days. But because we're remote, I couldn't slowly build it up because it's just too far between we see each other. Anyways, we've got 4.6 day of days. So you give yourself these heading. And what we just discovered is that there is this form of linear functions that are called slope-intercept form. And they come in the form y equals mx plus b. All the equations we just saw were all in the form y equals mx plus b. And what I was hoping you would discover and see, many kids did in class, was that all those equations, it starts y equals the slope was then being multiplied by x, and then it was plus the y-intercept here. But to be more specific, it's actually the y value of the y-intercept. And that's every time. All those equations, if they're in this slope-intercept form, the slope is next multiplied by x, it's the coefficient, plus the y value of the y-intercept. I know. It's pretty cool, actually. Right? Yeah, and so mathematicians are very boring. I'm sure you can guess why we call this the slope-intercept form. Well, because the slope's there and the y-intercept's there? Exactly. Okay, so our objective today was to write an equation for this line in slope-intercept form. Okay, we can do it, right? We just have to write an equation in y equals mx plus b form, just like all those other ones, where m is the slope of this line and b is the y-intercept's y value. So it's kind of like just plugging in. All you have to do is find the slope and find the y-intercept, or the y value of the y-intercept. And if we look here, boom, what's the y value of the y-intercept? 3. You just plug it right in. The slope, well, we learned how to find slope. Because we have the graph, we can just do rise over run. The rise is 4. The run is 2. So we have a slope, and because it's a negative, right, slope, we have a negative 4 over 2. Is that it, Mr. Merriman? Did we write the equation for the line? Yeah, you did. This is the equation that they used to make this line. Boom, right there. To write an equation, just to reiterate, you find the slope and you find the y-intercept and you have the equation. That's powerful, okay? And so just so you're clear, it becomes even super easy if I just give you the slope and I give you the y-intercept. It's one of the standards. Can you write the equation in slope-intercept form? Yeah, it's just like this, Mr. Moran. Yeah, totally it is. Okay, so pause me. See if you can write the equation in slope-intercept form like we did up here. Okay, pause me, otherwise I'm going to keep going. All right, well, we just find our slope, which is 2/3. We multiply it by x, which is our, and then we just add whatever our y-intercept is, and 4. Is that it, Mr. Moran? Yeah, that's it. Okay, so this one's just as easy. Y equals negative 4x plus negative 3. That's correct. Some teachers don't like the double add a negative, and that's the same thing as subtraction, but I accept either. Okay. So those are our notes. I wanted you to discover it on your own. I could have just given you these notes. Maybe you'd remember, maybe you wouldn't. But I hope you going through this was a chance for you to discover on your own that linear equations slope y-intercept. It's great. It's fantastic. And so your homework tonight is doing that. Writing the equations in slope-intercept form. And then in 7, 8, 9, 10, 11, 12, you have to go about and find the slope and find the y-intercept and then write the equation. Okay? All right, I'll see you next class. Bye, everyone.